Good afternoon, everybody. Thanks so much for joining us. This is another one of our Next Wave STEM summer webinars, Making Drones Real by Interacting with Physical Objects. My name is Desmond Martin. I'm the program coordinator for Next Wave STEM. My professional background is actually in mechanical engineering, and I've been working in education, engineering education for K2 and now K-12 for the last about 11, 12 years. I'm really glad to have you with us today as we discuss in our series what we have been discussing, thinking about ways to empower you as educators to teach your students STEM in a hands-on engaging way, even while we're all having to make adjustments for teaching remotely and teaching at distance. It has been a time this past 3 months as COVID-19, the global pandemic has made the future unknown. But what we do know is that our kids deserve a really robust STEM education. So we're really glad to be with you and sharing some ways that we can do that with your students today. One bit of housekeeping, well, a few bits of housekeeping information for today's webinar is first that it is a webinar. I know many of us are probably Zoom experts at this point. We are in webinar mode, which means even though I'm sure you're very, very camera ready, you won't be heard or seen. Those mics and those cameras won't be open. However, that does not mean that you are voiceless. You can still communicate to either myself or my colleague, Segundi Chigani, who is monitoring the chat. You can communicate via the chat or the Q&A functionality. If I happen to miss something in the chat, Segundi will let me know, and she will also be really instrumental in providing information, relevant things that are good for you to know about in the chat as well. So that's the first piece of information. The second piece of information is specific to our Illinois educators. If you are an educator here in Illinois, we are providing professional development certificates. Today registers as 1 hour of professional development, and we want to make sure that you get the credit for the time that you spend with us today. So in the follow-up email, there will be that certificate for you to take care of. That certificate does not apply to other states at this time, but if you need proof of attendance, that certificate is going out to all of our participants today, and that should work. And then the third thing is that I'm very excitable. And when I get excited, sometimes I tend to speak quickly. You can jump in that chat and let me know that I need to slow down or need to go and cover something else. It is not closed at all. You can talk back to me as much as you like. But in the event that you do miss something or you have to just jump off a little bit early, no worries. We are recording today's webinar. In addition to having the certificate for your attendance being sent out, you will also be receiving a copy of the slide deck that I'm using for today's webinar, as well as a link to the recording of today's webinar. So those are specifically as your resources. They're there for you to take something away and hopefully apply them to your classroom, but also poke around through that material, let me know or Segundi know if you have questions, and we will be more than happy to jump into the weeds with you. So with all of that being said, we can go ahead and press forward. I'm super excited today because it's a little bit different. We've been integrating two technologies mainly during our webinar series. We've talked about drones on Tuesdays and 3D printing on Wednesdays, or not Wednesdays, but Thursdays. And today we're actually going to do a little bit of talking about both. We're going to be merging that technology. Questions that I've gotten about 3D printing in drones is whether or not you could 3D print your own drone, or different ways that we can make the drone we use work with students. What are actual capabilities? We'll talk about ways of expanding on your drone program using the technology that you might have available to you. So I'm super excited to jump right into it. Now, a great saying that I heard from a college speech professor was that an amazing place to begin is at the beginning. So really what we're talking about now is the beginning of NextWaveSTEM. NextWaveSTEM at its core is an education company that believes in empowering our students with technology. And that's a little bit different than making sure students are one-to-one with computing devices like iPads or Chromebooks. It's a little bit different than teaching really important skills like computer science. So we think about coding specifically. We believe that's really important for students to get hands-on with emerging technologies. And by emerging technology, we mean those things that are really new. Um, Thinking of robotics, 3D printing, drones, and AI. That's exciting for us because we know that the jobs of the future are going to be in those emerging technologies. And there's an amazing opportunity not only to prepare a really vibrant, really engaged workforce, the workforce that our young people will be. It's also an opportunity to solve some of the world's biggest problems. Even before a global pandemic, we had some massive problems that our world was facing and is continuing to face, whether that's climate change or food shortage, or even more close to home, making sure that we have potable water to drink. Those are some massive problems that we believe our next generation of scientists, technologists, engineers, and mathematicians will have the opportunity to solve. And so we want to make sure that they have exposure from an early age. But we also recognize, and really the core of what we're doing today speaks to the fact that if they don't have a teacher, they don't have access to the resources, it is impossible for them to learn about emerging technologies. So we empower you as the instructors, providing a curriculum, equipment, and training, everything bundles together out the door to get you pointed in the right direction. And with that being said, it's really, really important for us to think about what we can do even remotely. Um, so there are three things that we want to cover during our training today, during today's webinar. And we won't cover them necessarily in order or in the same amount of time. Not everything is going to get the same time priority, but we will cover these three things today. The first thing is that we're going to learn how to include real world objects in drone learning. Not all drones are created equal. They can't all do the same thing. And they don't interact with their environments in the same way. But we can learn more and more about how we can get involved and think about the actual real world applications for drone technology and communicate that with our students. The second thing you want to do is learn how we can use 3D printing resources to customize our drone experiences. That is really, really exciting to think about the different ways that the technologies that you may have available to you or that your students may have available to you can change your learning experience in a really, really robust way. And then the third thing we'll talk about is considering project-based learning opportunities. Integrating multiple emerging technologies lends itself really beautifully to the opportunity to do longitudinal project-based learning. There are so many different avenues that you as an instructor can go down, that your students and the student-driven work components of project-based learning will be able to take. It's super, super exciting. So at any time you have any questions, I'm going to remind you and really encourage you. Jump into the chat or jump into the Q&A and let me know, because we are here for the next, well, less than an hour at this point, but for the time that we have, 51 minutes, we're here to really chop it up and make sure that we give you some good resources to use. So let's explore the drone. As I just mentioned, not all drones are created equal. At NextWaveSTEM, we have a preferred physical drone that we use with our courses that integrates with the drone program that we use in order to program the drone to fly autonomously, but also to manually fly the drone and even simulate flying the drone autonomously. At NextWaveSTEM, we use TelloEDU, TelloEDU. We're a big fan of this, and if you've been with us before at any of our drone webinars, you've heard me talk about and show this program quite a bit. It's block-based programming. And the difference between block-based programming and what we might think about as traditional computer science is that block-based programming is very accessible, and it allows students who might not have had any experience with computer science to really jump in and learn concepts without being worried about really fine and honestly finagly details about coding. With block-based coding, you're dragging and dropping blocks of instructions to be executed by the machine or the computer. So you don't have to worry about a semicolon missing. You don't have to worry about a comma being in the wrong place. You don't worry about something disappearing in the middle of our code and being broken and then having to go back up and debug dozens or hundreds of lines of code. With bot-based coding, you'll know right away if your code is not doing what you want it to do. And you can troubleshoot and adjust that code by dragging and dropping and doing some typing. The second thing that I mentioned before about TelloEDU that I'm a huge fan of is the ability to simulate. For our students who don't have physical access to the drones, being able to program in an autonomous flight using block-based coding and then simulating that flight becomes a really, really powerful thing to see. They can actually not only use their imaginations, but physically see on their device, their iOS or their Android device, what's actually going on with their drone, how the drone would actually move, and whether or not those motions represent their intent. But another huge thing that we love about the TelloEDU application is that it gives live sensor output when connected to the physical drone. I'll talk about that a little bit more as well, but suffice it to say that really turns our drone into a scientific tool. Really, really cool to be able to measure from the different sensors in our drone and to think about the impact that can have on our students' learning. So this is really the digital component. This is the brain, this is the heart of what's going on with our drones as we fly, is this application that is free for students on iOS, Android, and will also run on Chromebooks. But the interesting thing about having the app is that we also want to expand beyond the app. For our students who have access to the drone, either through the school they're purchasing directly from NextWaveSTEM, for those who are intending to have access to the drone, something that we're learning more and more about is our ability to go one-on-one with technology, one-to-one technology for students. And this drone is something that's really useful. We can get a physical drone and really take our learning to another level. So just like we have the TelloEDU app, we have TelloEDU Drone. This is the drone that NextWaveSTEM uses for all of its drone programs. We have programs K through 12. We have a K through 2 airplanes and drones course. We have drones courses available for our 3 through 8, or 3 through 5 specifically, and then our 6 through 8s. And then we have a high school drone program. Every program uses the TelloEDU drone. And the reason why we use the TelloEDU drone is because we know some things that are really important when it comes to you as teachers and using drones. One, you don't want anything super, super fast. You don't want anything super, super big. And you also want something that's really easy to manage, whether that's flying manually or autonomously with your students. And this drone also flies really well. So it checks all those boxes that we're looking for. The drone weighs approximately 80 grams or about 2.8 ounces. That's a really, really useful feature when it comes to flying an educational drone because we don't have to register that drone with the FAA. The FAA requires that any drone above 9 ounces, actually you have to go through a process of getting a serial number and registering that drone with the FAA. And that's for kind of obvious reasons. If that drone flies into a sensitive area, or, and by sensitive area, I'm really talking about airports, or if the drone becomes lost or is operated in a way that it shouldn't be operated, when that drone is recovered, they would love to be able to know whose drone that is. With these drones, you don't have to worry about that at all. You can buy your bundle of drones and fly them as you like. The drone is also not particularly big. 98 by 92.5 by 41 millimeters means our drone is about 4 inches by 4 inches. Well, I'll do the best representation that I can with my hand. Think a small dinner plate. These fingers probably don't mean very much to you at all. But it's not the largest thing in the world, which is really, really important too. We've got lightweight, small form factor, not very much speed. In the same vein, our drone also has propellers that are just 3 inches in diameter. Having a really small propeller is really good because the propeller is the only thing that I would say is a consumable on your drone. When your drone crashes, I'll say that again, when your drone crashes, because your drone is going to crash. There's no one who flies a drone that hasn't also crashed a drone, because that's how you know you're a real drone pilot. When you crash your drone, these drones will not incur any real damage. And by real damage, I'm talking about the only thing that will chip and break is the propeller. And that's just fine. The propellers are completely replaceable. Each drone comes with a set of spare propellers. And if you burn through those spare propellers, you can easily purchase replacements for those propellers for just a couple of dollars. And you could expect those propellers to last you at least 3 months on end with constant usage. So our drone becomes something that's really easy for us to integrate, to go and use indoors and outdoors. And with respect to the functionality on our drone, we have some built-in things that make it really easy for us to use our drone in some really useful ways. Things like a laser rangefinder, so the drone knows how close it is to the ground. Things like a barometer, so that we know how high our drone is in the air column and we're not violating any airspace rules. We have the ability to connect the drone via Wi-Fi. That is the primary way which we fly the drone manually and send the autonomous, the robotic controls to the drone. And we have a camera, not the best camera in the world, just an SD camera, but something that will allow us to record video and be creative in some really interesting ways with our drones as well. So this is the part where we ask for a little bit of participant interaction. I remind you that the chat and the Q&A functionalities are open as well. And just a really basic question here, which may be useful to think about. We know that our drone is not the biggest drone in the world. It's about 4 by 4 inches, and it's about 3 ounces, 2.8 ounces, even with the battery inside of it. What can a drone this size interact with? Thinking about physical things that the drone can do. What could you imagine this drone is able to do? There's no such thing as wrong answers. We'd love to hear your ideas. So I'm actually gonna be quiet for a little bit while those fingers are typing, and we'll get a little bit more input. What can a drone this size actually interact with? And we just had a comment come in for the Q&A, and a really, really salient comment. The propellers are a little bit different. They are actually rotational. That means that one set of propellers is designed to rotate to the left. Another set of propellers is designed to rotate to the right. There are special markings on those propellers. You've got a manual that comes with each drone, and you can easily figure out which drones go where. Thank you so much for that comment. So to our question of what the drone can do, we got an answer from Jeff who says visual feedback. Absolutely. Really, really cool thing to be able to fly a drone. And as we're flying the drone, see specifically what is in front of our drone. One of the most wide used applications for drones is actually suspending camera and audio visual equipment. Got another comment about students taking drones out to the football stadium. Yes, drones are really good for videography. You can go online and find some really, really amazing shots, both for movies and television, but also thinking about sporting events that are captured more and more by drones. And of course, they still have limitations. Those cameras will only be so big. The flight time will only be so long, but a well-organized drone program can take your videography to the next level. So at NextWaveSTEM, and thank you so much for those answers. Those are really, really good things. Yes, track. Also, the track running club, Patricia, that'd be really cool for your track athletes to be able to see a drone flying and recording. That's much better than the handy cam footage that I got from my high school baseball games. I'll tell you that much. But at NextWaveSTEM, we think about drone interactions just breaking down into two particular pathways. The first we think about as being digital interactions and then physical interactions. And I will also talk about the difference between those two things and how we can use technology like 3D printing to expand. So the first is digital interactions. Digital interactions happen primarily through sensors. And sensors are actually a really, really easy concept to think about and to integrate into our learning, into our teaching with our students. Sensors are just the ways in which a machine or an object knows something about the world outside of itself. If your human body was a machine, your eyes will be sensors, taking in light. Your ears will be sensors, being able to distinguish very fine changes in air pressure, in sound waves, those actual physical waves going through the air to hear things. Your tongue would be a sensor, along with your nose, distinguishing actual chemical differences in substances through taste and smell. Your skin would be a sensor, being able to detect differences in pressure and temperature. Those things allow us to know what's happening around ourselves. And in the same way, when you have a machine like a drone that has sensors, they're doing the same job, letting the drone know what's happening around itself. And also the drone's orientation in space. A camera takes in light and gives us information. The drone has a digital thermometer that's able to measure the temperature of the ambient air around the drone. There's a laser rangefinder so that the drone knows how close it is to an object underneath it. The lower right-hand picture shows on the left side of the drone the actual lens for that laser rangefinder in such a way that in that upper picture, that lady can hold her hand underneath the drone and the drone will actually hover away. So we have sensors. Those are digital interactions. The ability for the drone to recognize what's happening around it and kind of respond accordingly. So that's one way our drones interact in the world around us. And a lot of us are thinking about using those sensors. If we're filming sporting events, if we are filming the track club, or if we are even racing our drones or using our drones for those who are J.K. Rowling and Harry Potter fans playing Quidditch with our drones. That might be a little nerdy for some of us. I never read the Harry Potter series, but I did watch the movies. We can use the internal sensors of our drones to have some interactions with the real world. But the second way that we can interact with the real world is actually physical interactions. And this is where the ability to attach, build apparatus that can connect with our drones comes into play. That opens up our possibilities for the way that drones are able to fly. So what I'm actually going to do is switch things up and navigate away from my slide deck so I can show you what it looks like to really dig in to the way that our drone is able to be modified through 3D printing. Our TelloEDU drone does not naturally come with the ability to carry things. There's no hooks, there's no anchors, but through the power of 3D printing, we can actually design, print, and use these different apparatus. So what I'll do is I'll change this screen share to a new screen. So this may be familiar for some of you who have been with us in our 3D printing webinars. This is Tinkercad. Tinkercad is a free to use CAD, computer aided design software. It is cloud-based. You don't have to pay anything for this. Your students won't have to pay anything for this. You can log in and create an account, create a teacher's account. All of this integrates natively to Google Classroom, or you can have your classroom, your students nested underneath you as the instructor natively in Tinkercad. And the really useful way that we use Tinkercad is that we have the ability to simply drag and drop different shapes. By dragging and dropping, I'm going to quickly manipulate the view a little bit. By dragging and dropping, grabbing manipulation points, I can resize, I can rotate, I can change the elevation of shapes, and I can orient my shapes at a bunch of different angles. I'm not going to go into a really robust demonstration of Tinkercad today, just because in our Thursday webinars, we've done a lot more with respect to digging into Tinkercad. Some of you may also be very familiar with Tinkercad already, but suffice it to say that if you are a clever designer and your students are certainly clever designers, you can use addition and subtraction of solid shapes to create some very robust shapes as well. Now, the amazing thing about Tinkercad is that just like another CAD design software, we're able to actually import and export 3D printed designs. So that means that other people can design 3D printed objects and we can bring them into the software and we can manipulate those objects in our 3D printing software as well. What does that look like? Well, I'm so glad that you asked. I'm actually going to delete this box that I've just pulled out and get rid of that. And I'm going to navigate to a new web page. This web page is called Thingiverse. Thingiverse is an example of what's called a 3D printing library. These 3D printing libraries are free, once again, free open source places to find all kinds of useful 3D printing projects and 3D printing files. One thing we talked about last week was actually the ways in which people are actively fighting COVID and stopping the spread of that virus by 3D printing. They've been doing that for months and months on end now, and you can find those files to 3D print personal protective equipment here on Thingiverse. But today, we're specifically interested in the TelloEDU. By searching for our actual drone platform, the actual physical item that we use. Oh, I got a search that popped up, nothing. Well, let me try this. I'm actually going to make those all one word. Nothing again, and now I'm just going to search Tello. There we go. By searching for the proper term, by knowing your search semantics, you'll actually pull up files that have been uploaded by other users and other creators, and all kinds of things. In this case, I'll click on this particular file. This creator recognized that the Tello doesn't have landing gear, doesn't have an actual skid to allow the drone to land. Now, the drone has these 4 rubber pylons that serve as landing gear, but say we're in a situation where we're using our drones mainly outside. As we're flying and landing, we would much rather keep the propellers higher off the ground. Let's say there's higher grass where we're flying. Things like a 3D printed landing gear become really useful attachments. And in that same way that we found landing gear, there are a couple of other useful attachments that people have designed for the TelloEDU. Things like a different style of landing gear or a mirror clip. But something that really struck me scrolling down and looking through the way that people have used Tello previously is this particular object called the Tello egg flopper. This immediately struck my interest. I'd imagine that it would strike your interest as well. This person actually designed a clip-on egg carrier for the drone. And I investigated this a little bit more. They tried to put a real egg inside that egg carrier and found that a real egg was too heavy. But one of those plastic Easter eggs that you would use to keep candy in works wonderfully inside of our egg carrier. This 3D printing community in general, as a global entity that's working to improve our education, has provided us with a platform with which we can help our students learn more and more about how they can expand on technology. So scrolling down here in Thingiverse, there are thing files. Those thing files are in a file format called STL. That stands for stereo lithography. And that is the standardized file format in which your students are going to do the majority of their 3D printing throughout their entire lives. It's been around for about 20 years, so it's relatively young. Well, actually longer than that, more like 30 years. It's a relatively young file format compared to something like a Word doc, but it is a file format, just like Microsoft Word or Excel or PowerPoint. You can download it and upload it. It will go into Google Drive just fine. Most of them aren't very, very big files. In this case, this file is only 214 kilobytes. So I will actually download that file. And just like I can download this file, I can now swing back over into Tinkercad and I can import this file that I just downloaded. So clicking on the import button, I'll actually just drag and drop our Tello egg flopper up into the space. And it's going to give me some information. The name of the file. It's asking me about scale. Do I want to keep it to its original size or do I want to adjust it? It's letting me know what those dimensions are. And then I hit import. After a little bit of math and a little bit of processing, our Tello egg flopper has imported. So right away, just out of the box, using CAD software and our ability to do some some fairly basic searching through resources, free resources, we've actually expanded what our students are able to use. Our Tello egg dropper actually would clip onto the drone. I'm going to center this piece, adjust it, would clip onto the drone using these small clips at the bottom. And I'll actually zoom out and rotate this so we can imagine how it would be oriented on the top of our drone. So that's our 90-degree view of our Tello egg dropper. Now this is all fine and good by itself, but Tinkercad also gives us the ability for our students to prototype and design because it is a computer-aided design software. That means that in addition to just dragging and dropping out geometric shapes, I can also drag and drop out actual characters, things that are extremely useful for us to be able to use. So I have a couple of different distinguishing shapes. I have this basic shapes menu over here with things like parabolas and pyramids and tubes and some other useful shapes. But what might be even more useful is if I scroll over to characters. And then I've got some different shapes, including the ability to grab a standardized egg shape. So with this egg shape, I can actually manipulate and imagine, or my students can imagine, what it might be like for an actual egg to sit inside of the egg carrier. Select everything so we can see this a little bit better. We get a sense of how this shape sits in. But let's say that, you know, it's a couple months past Easter. those Easter eggs, those plastic eggs get lost. They end up going any place and every place. Well, that's okay, because there are other much more common objects around our houses that we can model and mock up in Tinkercad. Let's say that I have a sibling who really is not a huge fan of getting up and cleaning or counting their change. Let's say the piggy bank is spilled, the piggy bank is broken as we've been getting ready to make a new purchase. And we might want to use our drone instead to help clean up. Well, the Making at Home menu here in Tinkercad gives us those everyday household objects that we're also able to simulate and mock up. Things like, in this case, a penny. So I can pull out a penny that's actually to scale. This is actually the actual size of the penny. Each of these small rectangles that we see in our workspace is equal to 1 millimeter. And that means that our penny is actually to scale. I can adjust, just keeping everything to scale, and move my penny into our egg flopper, our egg holder, and I can adjust my penny as I see fit. And I can use basic copy and paste, Control C, Control V, to create as many pennies as I'd like, and imagine how many I can try to get into the space. So I've got a whole 6-cent design so far with my egg flopper. Right away, we see that the ability to pull out some pre-made shapes in Tinkercad, but then also import a new shape into Tinkercad to design, snap something onto the drone, expands its ability. Now, for our really, really clever students, things can go to an entirely different level, because Tinkercad is all about creating brand new shapes. Let's say that I don't need my drone necessarily to carry something on its back, like a penny or an egg, but I might want my drone to have a hook. I might want my drone to have the ability to hook onto a bag or latch onto something. Well, the great thing about Tinkercad is Tinkercad allows me to modify a design. And in Tinkercad, we modify designs not by drawing lines, but by actually using positive and negative space. So what does that look like? I am so glad you asked. In Tinkercad, we can erase and cut different shapes using negative spaces of shapes. So when I navigate back here to basic shapes, this box that I pulled out before, and then I'm going to pull out again, this box is a solid shape. But if we remember back to our high school algebra, solid 3-dimensional shapes just don't have to be solid. They can be negative. They don't have to be just positive. They can be negative shapes as well. So by clicking on this pattern that looks like a stripe, hovering over it, it says change to whole. That just means creating a negative shape. Now my box looks like this ghost box. That just means that that's space that's going to be taken away from any positive solid shape. And I can use that now just like an eraser. So I'm going to change my view. I'm actually going to adjust where my box sits in space. The tricky part about this is just making sure that the box is sized correctly and is actually cutting off the space that I intend for it to cut off. So I'm just going to manipulate the dimensions of this box in such a way that everything that I want to be cut off is cut off. The only thing that is not covered by my box is this small clip at the bottom. So what I will do now is I will actually select both of these shapes. I'll drag and highlight just like in Mac OS or in Windows, and I can group these shapes together, merging a positive shape and a negative shape. And when I group them together, it's going to do a little bit of math and then create a cut. So now I've imported the shape. I've mocked up kind of what I can do with the shape. And now I've changed the shape completely, where all I have is this clip left at the bottom of the shape. And this is great because this becomes a universal piece that I can use, that I can now attach a new shape of any kind that I want. And what kind of shape did we say is useful? Well, in this case, it may be a hook. So I can actually scroll back out to my shapes. I have basic shapes, I have text and numbers and characters and connectors. What's going to be really useful for me in this situation is going over to my shape generators. I'll use a feature generator in this case. And we've got a couple different things, threads and boxes and springs, really, really cool things that we can use. I'm going to scroll over because I don't want any of those. There are snap sockets, there are even propellers. One thing I won't show today that might be for another webinar is the ability to mock up and design our own custom drone in Tinkercad. That becomes a useful thing we can really do. I didn't find the shape that I'm looking for, so I'm actually going to click on another menu where I find all my shape generators. And I'm going to scroll because I know that there is someplace in my shape generators a hook. Let's see, quotes and talk bubbles, really cool things that we can use for different 3D designs. I'm going to scroll over very quickly, hoping for the best. And if I don't find my hook very quickly, I will end up just creating one. Okay. Well, since I haven't found my hook super quickly, I will actually just create a hook. So I'm going to go to basic shapes, and the basic idea of a hook is that it's a tube that has a rotation over. That means that we can think of it as maybe in this case a tube like this. I'm not going to make a whole lot of adjustment with the tube, but what I will do is quickly rotate my tube 90 degrees, move it over, and change how high it is. I'm going very quickly for the benefit of time and knowing that we've got quite a bit left to cover. I'll move our tube over more this way so that it's set on top. And in the same way that I kind of cut the shape that I had for the clip onto the drone, I'm also going to take a cylinder that's a hole. I'm going to rotate this cylinder as well. I'm going to turn that into a hole. And I'm going to adjust, well, much more better than that. So I'll change my view. I'm going to adjust the cylinder in such a way where there is positive and negative interaction between these two shapes. I'll adjust this down a little bit. I'll make the cylinder smaller. Adjust the height of the cylinder. And I'll adjust the cylinder this way as well. So now, checking my work very quickly. Now what I can do is I can combine all of my shapes and highlight everything here and group my shapes together. It's going to do a little bit of math. And now I've got this hook. Things are different color. What I'll do is I'll change one thing. I will unclick the part that says multicolored. And now I've got one piece. So this one piece, this shape, is now a hook that I've created that sits on top of this clip. And I can hang bags, for example, grocery bags, or string, or all kinds of different things that allow my drone to interact with objects in the real world. We've expanded the capability of our drones using another emerging technology. And if I don't have the physical drone, that's okay. I can still simulate my flights in the software. And if that's okay, I can still design my parts and components to add on to the drone, as well as we think about solving problems. So this can become a class project where one student might have a 3D printer or access to a 3D printing service, or we can even prepare this project in preparation for us having access to that physical technology back to the school. We're giving ourselves the flexibility to really make the actual hardware come alive for our students whenever and wherever we can get that hardware to them. So I'm checking my watch because time is quickly slipping into the future, and we still want to talk a little bit about our abilities to integrate project-based learning as well. So the big question becomes, well, how does project-based learning help here? What can that do for my learning if I'm using both a drone and a 3D printer to be able to do these more robust engineering design activities with my students? Well, the way that I like to think about it and share it with our educators, with you, is that we can think about project-based learning as not just being the dessert at the end of a learning unit. A lot of times, we all have at one point experienced this in our learning. We can think about the traditional way that we learn, which is a lesson followed by an activity, followed by another lesson, followed by another activity, followed by another lesson and activity ad nauseum until we get those intermittent quizzes to check our progress. So we get up to the big tests, and then we're done with the unit. For all intents and purposes, we're done. And then, and only then, we get this project that becomes like the fun thing, quote unquote, to do with our students, the fun thing for our students to do, which aren't really there to teach, but they're there to give our students another opportunity to get assessed. That's not really engaging for our students. Frankly, it can be really boring. Instead, we love to create this new model where our students are learning like they would do in the real world, which is the idea of project-based learning, doing as they would do in the real world, answering real questions, dealing with real problems. So instead of the project-based learning method or doing a project, the traditional method, we would love to move to a more project-based learning method. And the project-based learning method is really distinctive in that there are three kinds of different things that happen. Things that I have highlighted in green are primarily responsible or the responsibility of the instructor, of you as the teacher. That's a project launch that's helping our students figure out what the driving problem, the driving question is going to be. And that kind of frames up the thoughtful student-centered work that's going to happen, which is what happens directly next in blue. Students are going to have to make some decisions with your guidance, with your feedback about what actually is going to happen, what they're actually going to do to explore the solutions of their problems and progress in their projects, whether that is workshopping with outside professionals in a specific technology or learning more about the subject. That could be lectures, that could be research and homework, that can be labs, that can be all kinds of different activities. From there, you get a chance to benchmark those students. Is that activity actually leading them closer to a solution for that project? And then there's the reflection, the direct feedback. That could also be assessment. And then we kind of repeat that cycle, where after our students get a chance to reflect, after you point them in the right direction, even making recommendations about what their next student-driven activity should be, they get into the next round of activities: simulations, discussions, modeling, reading, interviews, quizzes. And then we have that cycle again where they benchmark and reflect and get into another round of student-based activity. And it's actually really interesting because you can think of any of our quadrilaterals in blue in this chart as being interchangeable. And it could be different for individual students or for groups of students. that creates this really, really amazing opportunity for students to not only learn more about the subject matter, to actually build a solution for their problem that can be used in the real world by real people, but to also learn the process by which they're building solutions. We know that there are many different ways, many modalities by which our students learn, and that winding path is exactly that, a winding path. This is differentiated for each one of our students and their students groups learning needs. So it's a really investigative, really powerful process that our students get to interact with. And we can see kind of how our differing technologies and what they learn and what they have to prove and what they have to design and build and 3D print and put together and test all fit into different student-driven processes. It becomes an incredible learning experience. So for our project-based learning experiences, the place to begin, and we won't go through everything that happens in project-based learning today, but it's useful to think about where to begin. It's the idea of the driving problem, the driving question that we can pull from the real world, that we should pull from the real world, either at the local, state, or national, or international level. The really easy way that we frame this is what tools are available for me to solve the problem. And in this case, it's your drone and your 3D printer. That helps focus and center our student learning and the activities that they are going to be pursuing. So when we think about driving questions using drones, the questions of how we might observe traffic in our neighborhood, or how we might establish safer drone flight, or how we might establish international rules for a drone, or in this case, we're focusing on physical objects, how I might use my Tello drone to deliver toilet paper from the kitchen to the bathroom. That becomes a real thing for our students to explore and consider throughout the project. That's just an example. Feel free to use that one. I'm sure you'll get a very juvenile laugh from your students when you give them that scenario as a driving question. So once again, these different avenues, these student-driven work sessions really become much more robust and much more rigorous because we're integrating emerging technology to allow our drones to interact with real objects. We kind of answered the question earlier. We're running a little low on time. What are some student networks that drones interacting with objects can do? That example of carrying an object or picking up a bag or even walking the dog, if we attach a leash to that hook, are all things that our students might want to explore and dig into more and more. So especially in that last about 5 minutes, I've hit you with a fire hose of information. There's so much stuff there. But now the big question comes as to what NextWaveSTEM specifically can do to help you. We talked a little bit earlier about programs that we're offering, about our solution. I actually am going to open the mic up to Segundi, who is our school partnerships manager, to speak with us some more about specific solutions that NextWaveSTEM is making available to schools. So Segundi, I'm going to take a tea break and I'm going to let you take it away. We're breaking up a little bit there, Segundi. And this is the thing about live webinars, ladies and gentlemen. We'll have real technical difficulties. Segundi is working on it on her end. She'll be with us in a second. Oh, there we go.
Is this a little better?
Yeah, that's awesome.
Awesome, cool. I know we're a tech company, and then you have a presenter who can't work their speakers, so you know it happens. Awesome. All right, yeah, wanted to give y'all a little bit of a overview of what we can do to work with your students and also to work directly with you moving forward. So a couple of things that we're doing here is so this first element is our live webinar PD session. So Desmond has been leading this for a couple months now. We've had some really good success, and I really love the engagement that we're seeing with all of our participants. So thank you so much for jumping in and making the conversation a little bit more lively. This is going to continue. Please sign up for more. Other couple things that we're doing is we are working on getting some of the stuff to students directly. So there's an online experience where we have a live instructor who will lead classes. All they need is all the students need is an internet connection and some sort of device. They can take our courses in robotics, 3D printing, and drones. Our other experience is a hands-on experience. So we'll have the live lesson, and then we will be sending STEM kits to these students. So it's the same classes, but with robots. So they'll be with robots, drones, or printers. So they'll be building robots, flying the drones, printing out their 3D. I apologize for the noise in the background. There's some STEM learning happening very intently with Legos back there. So, always on topic. So yes, if you're interested in either of these, you can definitely reach out to Desmond or myself. We're happy to talk you through this. We also have some summer camp offerings that we're doing this summer, which is 5 days in a row, a couple hours a day for students to have exposure to that. So if you're interested in a camp option, talk to us and we can get that going for you too. Thank you, Des.
Thanks so much, Segundi. We love being live and in action at NextWaveSTEM. We're not just educators and curriculum developers, we're parents and we're living real life out here just like you. So definitely appreciate, Segundi, you jumping in there and helping describe a little bit more of what's going on in NextWaveSTEM. And once again, our emails are really, really easy. I'm Desmond at NextWaveSTEM.com. My colleague Segundi is Segundi at NextWaveSTEM.com. You can reach out to us for any more details that you might have about the curriculum or the actual way to connect with the school. I've said a lot. I've said a whole lot. I want to give you the opportunity to ask questions. With this much information, you may be deer in the headlamp, or you may be really satisfied, but we want to make sure that you have the opportunity to ask some questions that you might have as well. We'll give a couple minutes for questions, just in case anybody has any. We are in the clear so far. Oh, yes. So really good question. Where do we get the drone kits and how much are they typically? I'm going to connect you directly with our school partnerships manager, Jeff. We do sell the drone kits in bundles of 8 that have extra batteries and chargers, have everything that you need to be able to sell the drone. So we'll make sure that Scunny reaches out with you on pricing. One thing that I do also want to mention is that because each of you is a participant in our webinar today, you'll be receiving a discount on our full bundle, curriculum, training, and pricing. So that means you'll have the drones, you'll have the curricula, and you'll have access to 6 hours of training in the curricula to make sure that you're able to execute the program. We want to make sure that you have what you need. So we're going to connect with you after our webinar today, Jeff. Thanks so much for asking. And of course, if you have any questions about anything else and you want to reach out to me after our webinar, or you just need some time to mull over in your head what your next steps are going to be for your drone program or any STEM program, you can reach out to us directly. Segundi has dropped both of our emails in the chat. That's my face in black and white on the middle of the screen, and my email, Desmond at NextWaveSTEM. You can also find us on major social networks at NextWaveSTEM. If you're on Twitter, LinkedIn, Instagram, and Facebook. No TikToks yet. We might work on an intern for that a little bit later, but not so far. And there's another question. How long does it take to get mailed out if students want a kit? We do not start school if we don't start school in the fall. Great question. Generally, when we get your order for a drone, that drone will get from that order process to your student, making sure that there's no purchase order finagles or anything like that within a week. Shipping is not terribly long at all. So we can also expedite and make sure that the turnaround is quick on that. It just just depends. But under a week, we're very confident that equipment gets to our students. Really good question, Patricia. And we'll also reach out to you just to get a little bit more sense of your situation, make sure that you have what you need as well. So with that being said, I just want to thank you all so much for attending our webinar today. I'm inviting each and every one of you, if you've got the time and you've got the interest, to join us in our next webinar on Thursday at 2 o'clock Central Time, where we will have the opportunity to talk about technology for good, 3D printing for PPE, that's personal protective equipment. We'll dig more into how you as a teacher can lead a PPE program, teaching your students how to solve some real questions and deal with some real issues and do real good. We hope to see you there. But in the meantime, stay safe. And the weather is as good as it is in Chicago. Enjoy the rest of your day, and we will speak with you soon. And Jeff will make sure that you get an invitation to that meeting as well. Thanks all. Bye.
Done?